ഓക്കെ. മൈക്രോഫോൺ
ഇതാണ്
വെക്കാമോ?
ഇതിലെടുത്തിട്ട്
അത് പോതും അതൊന്നും എല്ലാ അത് തന്നെ നോക്കുന്നത്.
ஏர்பட்ஸான கனெக்ட் பண்ணியிருக்கீங்க. காட்டுறது
இது
க்ளோஸ் பண்ண முடியுமா? அதாவது இப்போ இது ஸ்டார்ட்லாம் ஆகல.
இல்லை இப்போ போயிட்டு
இருக்கு. சவுண்ட் வருதா? சரி ஓகே, நான் பேசுகிற கேட்குறேன். சரி
Okay, sorry for the inconvenience. So there was some audio problem. I think you're able to hear me now. So we'll continue. So I just started with the Internet of Things, and so when we talk about Internet of Things, so myself, so first I'll just introduce myself. So myself Nivin, I'm from Pantechelearning. So I'll be leading the 2-day session today and tomorrow, and so we'll just these 2 days we'll talk about Internet of Things and how we can apply Internet of Things in machine learning, how we can use Internet of Things in machine learning applications. So first we'll go through Internet of Things, and then we'll see some machine learning application, and we'll see how to implement a IOT communication protocol in that machine learning application. So first we'll just start with the Internet of Things history. So to talk about Internet of Things, first we have to start with the Internet itself. So the Internet revolution. So this slide here is an example of different eras of Internet. So Internet of Boffins is the initial stage. So that was when the Internet was created. So it was at that time it was a private network. It was created by US Defense Department for interlinking all the different research and development centers across the country. So so there are like so many different research development is going on under the defense department of any country. So whether it is purely military or medical or any other kind of technology based research, it is science or technology based research, there are so many different research that is funded by the defense department or the government or a country's government. So at that time in US it was necessary to interconnect all these research centers so they can easily intercommunicate and make the research process efficient. So at that time it was a private network, so that means only these people who are working in this institute, they were the only people who were able to communicate through the network. So at that so that's why it's called the Internet of Boffins, because Boffins is a slang word for academics, people who are researchers and professors. So that's the term. That's the meaning of the term in Boffins. Then the second era is Internet of Geeks. So in 1995, the internet, in early 90s itself, internet was made public, and but at that time it wasn't that popular because it didn't have that much useful applications. It wasn't very useful for most people because it wasn't the same internet that we know as today, because we know as internet today, because it was just basic things that we can do. So only people who are really interested in technology, those were the people who were using internet at that time. So so that's why it's called Internet of Geeks. Geeks means people who are enthusiasts about technology and science or any kind of field in specific. So at that time only people who were using the internet was these people who are really interested in technology, because there was not that much useful applications in internet. Then Internet of Masses. So we know about the IT boom, the 1990 late 90s and the early 2000s. how so many new companies started to how so many new IT companies started, and so many new businesses started based on internet, and so many things got integrated into internet. So like at that time in 2000s, if you take like things like even government was using internet, still the same way they are using like for different type of applications like job applications or exam applications. Internet was used at that time to do that. So people were able to do that, but still at that time it wasn't still affordable, because you need a system, you need a personal computer, and you need a internet connection. So high speed internet connection at that time was very expensive. So that's why it's also the era of internet cafes. So internet cafes means like there will be a place where you can go, and there will be multiple systems, and they'll have high speed internet, and you can pay a small amount like 10 rupees or 20 rupees per hour, and you can browse, and you can download things, you can do whatever you want to do at that time. So then you can so that is much more affordable. So then came the time of mobile internet, where the people were able to access internet through their mobile phones, their handsets. So at that time we had Nokia handsets. Using the Nokia handsets, using GPRS system, we were able to access the internet. It wasn't that fast like the 4G or 5G network that we have today, but it was still useful in the sense people were able to more people were able to access the internet more affordably. Like the recharge, you have to do special recharge for data for internet, but still it is affordable compared to a high speed internet connection that you can get at your home, like an optical fiber based high speed internet connection that you can get at home. It is much more affordable than that, and also these handset devices are much more affordable. You can buy one under 10,000, and you can use GPRS networks too, and you don't need to have a separate ISP, internet service provider. You can use your own mobile network provider. The mobile network provider will act as a ISP, act as an internet service provider, and you can use at that time you can use more options like you can you can use Google, you can use Facebook. So you can use simple things like that, or you can check your emails. So it wasn't exactly like the smartphones that we have today. And also like things like Nokia developed like Symbian OS, and with that they were able to use internet much more easily. People were able to use internet much more easily. And also BlackBerry came into market, and they developed a set with which we can easily use internet. It was specifically designed to be used for internet usage. So then at last we have Internet of Things, where we have multiple type of devices, classes of devices can be connected to the internet. Like we have smartphones from 2012, from beyond we have smartphones, and we can connect our laptops or iPads. Different devices can be connected to internet. So throughout these eras, what we can see here, the common thing here, what happening here is the number of devices connected is increasing. So Internet of Things means there is only limited number of devices connected, computers connected to the internet. Then that increased from 1995 when the internet was made public. Then again increased when after the IT boom, and after so many starting of different IT companies, this has, and different type of internet-based businesses started at that time. So because of that, the number of devices again increased. Again, mobile internet, it is much more affordable. So again, that increased the number of devices. At the end, the 2012 and beyond signifies the era of automation, where everything gets automated, and automation becomes much more liberal. Like it doesn't have to be a single person can on their own, they can develop a automation system, whether it is software based or hardware based automation system. They can develop their own automation system, and automation system means internet is an essential part of our life at that time. So any device that is automated, that is fully automated, that can work without a human intervention, without any human intervention. So by connecting that device to internet, we can use that device for so many different type of applications. It is so the use cases are infinite, like unlimited number of use cases are there. So still we are exploring that. So that is the main factor here, the number of connected devices. And then Internet of Things was made possible because of the automation, era of automation. So why internet anytime, anywhere, any person? So obvious things like that. And what is internet? No one owns it. It has no formal management, as it was originally developed by Department of Defense, DARPA. This lack of centralization made it less vulnerable to wartime terrorist attacks. To access the internet, an existing network can pay a small. So it is a collection of small networks. So that's the thing about internet. It does not have any formal organization. So anyone can create a small network, and they can connect it to a bigger network, connect to World Wide Web. So the term was coined by the person called Kevin Ashton in 1999. So Internet of Things is network of physical objects, devices, vehicles, buildings and other items embedded with electronic software, sensors, connectivity. So that this is just one of the basic definitions of Internet of Things. So it is like it is any kind of system which does not have an inbuilt, which does not have an inbuilt ability to connect to a network, but then it will be embedded with an electronic hardware that is programmed with some kind of software which is able to access the internet through the existing TCP/IP network. So then what the purpose is, basically it is collection and exchange of data. So any kind of internet based application that we use it is the basic thing that we are doing here. We are collecting data and we are just sending data. So exchanging of data. So that's what we. So then machine to machine communication, now intervention, human intervention. So this is an example of Internet of Things, how we can implement Internet of Things in a specific use case, like specific case like Internet of Things at a campus, different things that we can do in a campus. So then number of devices. So this chart here is showing the like the same thing that I said while I was discussing about the first slide, discussing about the eras of internet, the number of devices connected and the human population. You can see at the end 2020 the number of devices connected was 7.6 billion, and the world population world population is 7.6 billion, and the number of devices connected is 50 billion. So you can see per person 6.58 devices are connected to internet. So that means obviously most of these devices has to be automated. A single person can only use 1 or 2, maximum like 3 devices. But there are 6.58, almost 7 devices are connected to internet per person. And so that means most of these devices has to work on its own. So that's the relevance of Internet of Things in this era of internet. Then hype cycle, how the Internet of Things is staying high with its expectations high in Internet of in the hype cycle. Then different layers of Internet of Things, like people, process, applications, data analysis, data ingestion, like people and process. So whatever we develop, it's always the end user is a person or humans. So so then there is a process through which we can access the application. So the transformational decision making based on thing, app, and data. Then underlying the people and process, there is applications. Application means it is a software based application. Could be a software based application. And then data analysis. So data analysis, things like reporting, mining, machine learning, or big data, harvesting, storage, all these comes under data analysis and data ingestion. So data analysis examples like getting the data, like for example, one of the examples are like personalized advertisements that we get today, like so it is based on analysis of our like browsing history, how search history. Based on that, how like what are the products that we buy. Based on that history, it will use that data, and it will use machine learning to analyze the data. And based on that, then using data ingestion like big data, things like big data, that data is provided to you in the form of different suggestions for different products or different things that we might need. Then global infrastructure, things like cloud infrastructure or public, private, hybrid managed cloud infrastructure, different type of cloud infrastructure like Google Cloud or AWS or IBM, different type of cloud services, or Mathok's ThinkSpeak cloud. So different type of cloud, all cloud platforms that already exist that can be used by end user. So it is most of these cloud services have free options. So that means you can any person can start experimenting with these cloud services on their own without making any payments. So if you want to use it for any commercial application, then you might have to pay money. But if you are using it for like simple personal to make different type of personal applications, then you can use these free services. Then connectivity, like communication protocols, network, all these comes under connectivity. Wi-Fi, like different protocols in the sense like Wi-Fi or different like TCP/IP or HTTP, MQTT, SMTP, this type of protocols. Also, all these. So the Internet of Things users make use of all these different protocols, and then at last things. So necessarily it could be devices. So Internet of Things doesn't always means there has to be a standalone embedded system. It could be Internet of Things could be implemented. It's already implemented in your mobile phone in different ways, in different applications, or it could be a smartwatch where it is continuously analyzing, and it could be connected to internet, and the data, your health data, could be uploaded to the internet, and you can get some analysis report from that. It could be uploaded to some cloud where it is analyzed using machine learning, and that output can be you could get that output on a weekly basis, something like that. So that could be the end device doesn't have to be a simple microcontroller or a simple board computer, like a simple microprocessor or something like that. It could be a device like a mobile device, a mobile phone, smartphone, or a smartwatch, or your laptop itself, PC. Could be anything like that. So at the end, the last layer is devices, the hardware devices, such as sensors, microcontrollers, microprocessors, or other kind of mobile or other kind of computing devices. Then how they can communicate. So So first we will start with the sensor. So what is a sensor? Sensor is any device that measures a physical quantity and converts it into a signal, which can be read by an observer or by an instrument. So different type of sensors, like these are like different type of sensor, like water level sensor, light intensity. So water level sensor is this sensor we can use for measuring water flow. So this is not level sensor actually, this is water flow sensor, which measures the flow intensity of any liquid, not just water, any liquid. You can use the same kind of sensor is used in like petrol pumps. So when you go to petrol pumps, you can see some petrol pumps. You can on the pump you can see there is a thing inside that is rotating. So that rotation, it's counting then we can count so as the liquid is flowing through that funnel, it will make the rotor inside. It will make the rotor rotate. As each rotation will be registered to a microcontroller, and the microcontroller will count the number of rotations. Based on the number of rotations, we can calculate the amount of liquid flowing. So every sensor uses some kind of mechanism like this. For example, this current sensor here. So this is a AC current sensor. So you can measure AC current using this sensor. So this is a coil. This is a simple coil here, and through this coil we can put the AC, the wire, the phase wire, and as the electricity passes through the wire, some voltage will be induced. There will be induced current in this coil. So that induced current, the intensity, the value of that induced current depends on the current that is being passed through that is passing through the phase line here. So it uses just the principle of mutual induction to measure the current. So this is called a CT, a current transformer, which uses this simple mechanism to measure the current intensity. So there will be some. So the primary is the wire which is passing the electricity, and the secondary is the coil inside this sensor inside the sensor. So so there will be a ratio between the primary and secondary. Based on the ratio, we can measure the current. Then another type of current, like DC current sensors. Then two type of sensors are there, digital and analog sensors. So then type of devices that can be used for internet applications. So if you are making some kind of machine learning or image processing standalone application, then you might want to choose a single board computer like Raspberry Pi or Jetson, different type of Jetson boards. More than Raspberry Pi, it is recommended to use a Jetson boards. So Jetson single board computers are from NVIDIA. So NVIDIA, they make graphic processors. They make graphic GPUs, graphic processing units. So those boards they can be used in very high-end image processing applications. Also, we can use Raspberry Pi, but it will be less efficient than it. And also, NVIDIA means we can use CUDA. And CUDA hardware is already inbuilt in NVIDIA processors, GPUs, so that means it is much more the image processing or deep learning or machine learning program application can be run much more efficiently using an NVIDIA board. And if you have some kind of controlling or basic communication application, then you can use a microcontroller, or you can use a Wi-Fi based microcontroller like ESP32 microcontroller. Then big data, we have seen all these. Then applications of Internet of Things, predictive maintenance, sensors on machinery, monitoring their performance can predict the maintenance it needed to reduce the downtime, preventing the costly breakdowns. Then quality control, IOT sensors can detect defects in real time, ensuring that only high quality products are shipped. or supply chain optimization, tracking and monitoring of goods in real time and end-to-end. So all these applications combine both machine learning and Internet of Things. So the mission here, the predictive maintenance, the name is it's a predictive maintenance, like it continuously analyze some machinery, and based on the current today's readings, it can predict whether the machine is going to break down or it's going to run smoothly in the future. So then quality control, like any kind of product quality control. Then supply chain optimization, tracking and monitoring. So this is logistics. Logistics is made very efficient by interconnecting all the different parties. Healthcare, smart hospitals and medical equipment monitoring. So this is a very essential application, like medical equipment monitoring. Medical equipments need to work very efficiently, and any fault in them can even cause like fatality. So to avoid that, we can use Internet of IOT based, machine learning based devices to monitor these equipments. Smart buildings, energy efficiency and occupancy monitoring. So to reduce the power consumption, we can use these devices. So these, I'll just go into like the actual real world examples of these things, like neat learning thermostat is one of the example. In most places in India, this is not very necessary because we don't use the thermostats here. So in foreign countries or even in north of India, like places like in Delhi or in like Himachal Pradesh or Kashmir or places like that, both heating and cooling systems are needed. Or if you take simply we can go places like in Europe, countries like in Western Europe, where when it is summer it is very hot, and when it is winter or any other time, when it is winter, it is very cold. So in every house or any office space or any kind of building, they need a HVAC system. So heat air ventilation ventilation cooling system, where in summertime it will act as a cooling system, air conditioning cooling system, and in winter time it will act as a heater that heats up thermostat that heats up the entire room. And this was a manual device, but now this device called NEAT, which is learning thermostat, learns the temperature you like and builds a schedule around you. So it can learn, and based on that it can build a schedule around you. And independent studies showed that it saved 10 to 12% on heating bills, 15 on cooling bills, 15% on cooling bills. So in under 2 years it can pay itself. So that is a very good investment. And then smart lighting systems like Philips Hue, Lift. These are like Philips Hue. Philips Hue is not just a smart bulb; it's a lighting system that smart lights Hue, and smart controls will forever exchange the way experience light. And then the different type of fitness trackers like smart watches like Apple Watch, Garmin, or Fitbit. So this is an example of Fitbit, called Fitbit, much more affordable than high-end smartwatches like Apple Watch. Then connected cars, Tesla, BMW I series, all these are connected cars. So it's like Tesla is connected to a network, and for example, if you take the Tesla example, the Tesla is like in your Windows system, the Tesla can update its software, update its automotive software every month. So that if there is an update, it can automatically fetch the update from internet. If there's an update from the server, and it can update it. So this update means it can even improve the efficiency of the how fast the car is going. It can even increase the speed of the car, like the performance of the car. From last month, after the update, it can even improve the performance. So that is the car. The driver doesn't even, the owner or the driver doesn't even They don't have to be aware of the system. The car itself will connect to the internet, and from the server it will just update, and it will update the software. So there is example in case of Tesla cars. Software that enables autopilot mode and self-driving modes in cars, advanced driving assistance systems. ADAS helps to drivers reducing the manual task. It helps to improve both safety and convenience. So it is basically for safety purposes. ADAS is an ADAS system. This special IoT feature helps the driver by taking control of the car in mishaps and non-idealistic situations. One of the applications is the vehicles over-the-air update system. Normally cars are updated in dealership stores. As time passes by, the cars depreciate and the whole system becomes complex. So in case of Tesla, the driver, you don't have to go to a dealership store or a showroom or anything to update your software. You can just use the Tesla over-the-air update system will do that itself without your knowledge. You can do that, you can do what you want, and the car will update itself. The Tesla S model was the first of its kind that updated itself via the on-air updates. Then different type of instances like safety and security and traffic management systems. So we'll see one of these applications today. So we'll just go into the specific IoT application that we are going to use today. So we are going to use MQTT. MQTT protocol. So we are familiar with the internet protocols, different type of internet protocols. So this is a OSM model of any internet-based system. Like on top there is application layer. So we are only going to explore the application layer here, because we are going to implement internet we are going to implement an application with the internet application layer protocol. So each layer has their own different type of protocols, and at the end we have the physical layer. So application layer protocols, we can say like examples of application layer protocol. Familiar examples are like HTTP. HTTP is used for web browsing. It is a server to client, client to server communication protocol. Protocol. So it's an application layer protocol. Another layer like link layer protocol. If you take a link layer protocol, Ethernet, Wi-Fi, WiMAX, low rate WPAN, mobile communication like 4G, 2G, 3G. All these comes under link layer protocol. And then network layer protocols, IPv6, V4, 6 low WPAN. All these comes under link layer protocol. Then TCP, UDP or transport layer protocols. Then application layer protocols, HTTP, Co-op, WebSocket, MQTT, XMPP, DDS, AMQP. So two familiar protocols two protocols that we use every day on a daily basis is like HTTP and SMTP. Like SMTP is simple mail transfer protocol, which is used in email communication. And HTTP is used in web browser communication. So HTTP hypertext transfer protocol. So these are the different commands used in HTTP, and it's stateless. So each request is different of each other. So there is no so each request is initiated from without having any information about the previous request. So that's why it's called stateless. It does not have any memory. HTTP client can be a browser or an application running on the client. Co-op constrained application protocol for machine-to-machine communication, request response model, run on UDP instead of TCP. So the transport layer protocol is TCP instead of UDP, and these are the different commands used in methods used in Co-op. And WebSocket full duplex communication over single socket communication. It's based on TCP, client can be read. So these are the different type of protocols, and the one that we are going to use here is MQTT. So MQTT means message queue telemetry transport. It is based on publish and subscribe model. So it uses MQTT uses publish subscribe model. So and use of MQTT broker as a server. So in case of HTTP, so if we take the example of HTTP, it is client to server or server to client communication. Directly client to server or server to communication, server to client communication. But in case of MQTT, there is a sender, a publisher, and there is a broker in between, and then there is subscribers. So the subscribers are receivers. Subscribers will receive the data from the publisher. So it uses the same basic real life idea of publishing. So publishing, like we can say, like publishing like magazine publishing, for example, magazine publishing. So if you a magazine is being published, like a weekly magazine is being published, like the week magazine, you can subscribe to that magazine, and whenever there is a new copy, you will get that. If it is like by post or something, they'll send you the magazine. So you'll get that one. So you don't need to be worried about when are they going to publish, or you don't need to know the specific time. Obviously, every Monday or every Sunday you'll get the mail, and you'll get the weekly magazine every week. So that is a publish subscribe. There is idea of publish and subscribe. There is a subscribing to that particular magazine, which is like we can say it is a topic, and the whoever subscribe to that magazine, they'll get that magazine. So it's the same thing like you subscribe to a YouTube channel. Whenever the YouTube the publisher, whenever they publish the new video, you will get a notification and you can watch that video. So that's the same idea is used here on a much more basic level for transferring basic data, like strings of data. You cannot transfer like multimedia information using MQTT. You can only transfer like strings of data. You can transfer sensor values, or you can transfer like count or different type of data, numerical data using MQTT. It's a very lightweight protocol. That's why it's used in Internet of Things, because in Internet of Things, the devices are very low-end devices with the low with the processing constraints, like microcontrollers or small single board computers. So these may not be able to use so also in case where there is the internet speed is very low. So used in places where memory and resources constraints are limited. So MQTT is a specific protocol that we are going to explore here. So before that, we'll just see a real-time machine learning application. So this is a simple object detection program. Here it can detect objects like this. Here I have a pre-built model. So here this is a pre-built model, cafe model. So it is using MobileNet SSD, and MobileNet SSD, like the name says, it is like the name says MobileNet. It is used for like mobile devices. Why specifically mobile devices means, if you take mobile devices these days, might not be the case. Like if you take mobile devices or small devices, their processing capabilities are very low. So that means we need to use. They may not have a GPU. So that means we need to use a much more lightweight architecture. So with the less number of computations. So this in case of in case of mobile-length SSD, it uses this technique called depth-wise separable convolutions. So this is different from a conventional convolution, where the whole convolution operation is done once. Like if you have a so this is an input image, 224 by 224 image pixel image, and it has 3 channels. and it has 3 channels, and that is then converted into a depth map by using depth-wise convolution, where the convolution process is split into two different convolutions. First a depth-wise convolution, then a point-wise convolution. So the advantage of using this is the number of computations. Number of computations is significantly reduced compared to a conventional convolution. Number of computations so that means the number of the amount of processing that is needed to process a single input frame is very less. So this is like a normal input image, like a 3-channel RGB input image with the dimension 224, and it is passed through these different layers, and then at last a cooling layer, and then we'll get the output at the end. So this here that means mobile. If you use the architecture mobile nets, it is a lightweight architecture. So these are the different objects that we can detect using this. So one of these objects is person. It can detect a human. So I'm going to use that to count the number of people in a room. So in a room, or it would be, you can implement this in a public bus, and we can implement we can count the number of passengers, and we can update that to the next stop. So people at the next stop, they can see that in at this, or they can use the mobile application. They can use the mobile application, and you can see that this particular bus is approaching the bus stop, and this is the number of passengers inside the bus. So you can implement such a system using this. So I'm just detecting person, and if the person is detected, increment the count. Then just display the count. Then publish that count to a using MQTT protocol. So I'm using MQTT here. I have a separate script for MQTT here. So this script is written as a module, a separate user-defined module. So it uses the Paho.mqtt client library, Python library, to access the MQTT broker. So we are using this test.mqtt.org broker here. So I can just run this and I can show you an example here. So this will just open my camera. And since I am the only person, it will just detect me and it will say number of people, 1. So I can just run here. So this is a command to run. So Python, obviously that to run the Python script, you need the Python command. And this is a script, the program name. And this is the auto text, the configuration text file. Then this is actual model that we are using. So this is a pre-trained model which can detect all these different objects. So we are just going to detect person. So only if person is detected, the count will increase. So I can just run this. I'm going to mention the source here. So I'm going to use my primary laptop camera. So you can see here, it's detecting me with a 99% accuracy. So it's very fast because we are using mobile nets. So mobile nets, we are running it in a system, in a PC. So that means it is very fast running. You can see how fast it is running, how fast each frame is being processed. So the number that is being printed here is elapsed, the time elapsed, and this number is actually the center of this bounding box here. So center of the bounding box, and you can see here number of people. So if I cover, you can see number of people, 0. And at the same, this data is being published using the MQTT protocol. I can use a simple script here to read that data. So I can just use this, will just print the data here, print the data, any data that is coming, it will print the data. So I'll just run the script. Before that, we need to do some changes here. We need to make some changes here. So for example, we are So like I said, it's a publish subscribe system. So there need to be a common link between the publisher and the subscriber. So to what we can subscribe. So we can subscribe to a topic. So this is a topic. It's a simple string. You can make up any kind of string. Like I'm just using this string here, person counting slash in node. So this is subscription topic, and we need to use the publishing topic. So here this is the pub function. Inside the pub function, I'm using the topic person counting out now. So person counting, this is a common topic between the publisher and subscriber. So the data is being published from the script here pub. So I'm calling the function, the method pub from the Python script here, and I've imported this script as Python script as a module in this main script here, and publishing the count value, the number value. So we'll just see the number, that's all we are going to see here. So if you want to publish anything else, you can just add that here. So we'll just see the number, we'll see how this works. So I need to use the same, so this script here need to subscribe to the same topic. So this, in my case, I'm using the same system because I don't have any other way to show you. But you can use your mobile phone. You can use an Android application for the same. So that make sure that both the broker servers and the this is common port number for MQTT. All these are same. So in my case, we are using test mosquito and so test .mosquito.org. So run the script. So connected, and you can see it's showing the count. It's just showing the count. I can just stop this, and we can just add number of people plus convert that to STR. Sorry, not here. See this, if this works. Just stop the program. Okay. And script. So you can see here it's printing number of people. So if I cover the camera, you can see the count is changing to 0, and it's very fast, receiving the data very fast. So this is just I'm using a very basic Python script here to receive the data. So if I can use the Python script, actually MQTT has client libraries in all different platforms. Like you can take Android or like Android or MATLAB or C, like in Arduino. They have client libraries in all these different platforms. So you can easily implement any kind of application. So if you want to develop an application using Python with some other kind of front end UI, then you can use this simple script to receive the data. So that's a very straightforward, simple implementation. So a connecting function, a message receiving function, then connect to the server, broker server, and receive the data. So that's our time. So we have to wind up the class now. So we'll see tomorrow. I'll come with another application. We'll see another application tomorrow. So here, this is hopefully this helped you in some ways. So this is just an integration of Internet of Things and machine learning. So thanks everyone.